Module Product Service Development for Circular Economy and Sustainability. The material selection to develop any product often requires a compromise between gross media effects that can be opposite or have contradictory objectives. In the previous chapters, a compilation list of the characteristics of the materials and the related processes were presented, with suggestions pointing to the circularity of the products. The choice of materials and processes that best meet circular economy objectives does not necessarily have to be the one best meeting the current company reality. For instance, the lightest materials will generally not to be the cheapest one, nor the one with the lowest embodied energy. So, how can we choose the most appropriate materials and processes? This is not an easy question, and usually the only solution is to find a balance among the different options. In the following slides, some suggestions and ways to resolve these trade-offs are presented. Weight factors. Weight factors method is appropriate to compare different alternatives using relative values. First step is to identify key properties or indices of the material or process we are working with. Since the absolute values of the different properties can differ widely and depend on their units in which they are measured, the second step is to calculate the relative value with respect to the largest index of this group of properties. That is, dividing the absolute values by the largest value registered in the alternatives we are choosing. Therefore, the largest one, after scaling, has value 1. Systematic trade-off strategies. Systematic trade-off deals with the choice of materials to minimize mass and cost while meeting a set of constraints, such as a required strength or durability in a certain environment, and also its final cost. It's important to keep in mind that a viable choice is the one which meets all the constraints but not necessarily is optimal for the either of the objectives. Penalty functions. Penalty function considers the case in which one of the objectives to be minimized is cost and the other is mass. The equation shown can be used taking into account that C represents the cost in dollars and M the mass in kilograms of a given product or material. Values for the exchange constant and exchange constant for ecodesign. Both methods are related to monetization of resources. Values for the exchange constant is the value of a unit change in a performance metric, usually measured or translated into cost saving. Exchange constant for ecodesign deals with the instrument that uses taxes, subsidies, and trading schemes to allocate a monetary value to resource consumption, energy, emissions to the atmosphere, and waste, effectively establishing an exchange constant. Some examples are the cost associated to 1 kilogram of weight of material saved, or the different cost of passive or active heating system. Finally, in order to clarify the concept explained, we are going to show two examples. The first one refers to the manufacturing of ceramic tiles. This manufacturing process is an energy-intensive one. The energy consumption takes place mainly in 3 stages: in the preparation of raw materials, in the drying of the ceramic tiles bodies, and the ceramic tile firing. Most of this energy required is obtained by the consumption of natural gas, and thus this is an important aspect to control if we want to meet the circular economy objectives. We are going to focus in the preparation of raw materials. Here, there are 2 alternatives, the wet route and the dry route. The wet route is the most common option. In this process, the raw materials of the ceramic body are subjected to a milling process of water. After this mixture, called barbotin, passed through a spray dryer to obtain granules. It is in this part of the process where great amount of energy and water are needed. Moreover, a heat and electric energy cogeneration system is installed at the spray dryer. Part of the cogenerated electricity is consumed by the manufacturing plant, and part is sold to the power grid. Then, dry root might seem a very promising alternative to reduce the high consumption of water and thermal energy, but increases the electric energy required. And it wouldn't be possible to have a cogeneration system. So, once here, what is the best alternative? The wet route with high consumption of water and natural gas but exporting cogenerated electricity to the power grid, or dry route with less consumption of water and natural gas but higher consumption of electricity? This is what we call a trade-off. Example 2. The car, economical cost versus environmental impacts. Imagine you need a new car. To meet your needs, it must be a mid-size 4-door family car with a petrol engine delivering at least 150 horsepower. Given all these requirements, you want the car to cost as little to own and run as possible. You are an environmentally responsible person. You want to minimize the CO2 emissions, as well as the cost of ownership. The choice to meet two objectives is more complicated than that of meeting just one. The problem is that the car that best satisfies one objective, minimizing cost, for example, might not be the one that minimizes other greenhouse emissions, and vice versa. So, it's not possible to minimize both at the same time. A compromise has to be reached, and that requires trade-off methods. The graphics show different car models. Vertical axis is the CO2 rating, and the horizontal one, the cost of ownership. The purple dots have higher values for both variables, and that's why they lie in the unacceptable quadrant. The blue ones either have lower costs or lower carbon, but not both. The red dot is the car recommended by a friend, but as we can see now, it doesn't seem to be the best option. And finally, the green dot is the cheapest and the one that produces less carbon emission. So, it is the one which ranks higher in both objectives. But, is this the obvious choice or it is not? Well, that depends on the value you attach to each of the objectives. If you think it is a good idea as long as you don't have to pay, the car marked as choice if costs matter most is the best. If instead you are ready to pay whatever it takes to minimize CO2 emissions, the car marked as choice if carbon matters most is the one to go for.